Is the universe connected at all scales? And if so, how do we experience it? In this episode, we discover that whatever we do influences the whole.
In the earlier episodes, we have discussed that space-time is not empty, that it's full of these fluctuation of Planck oscillators, and that these Planck oscillators can be thought at as little bits of information, that this Planck field, this granular Planck field that's occurring at the very fine structure of space-time, spins itself into protons, atoms, planets, stars, galaxies, clusters, superclusters, universes, each one being centered by singularity, by a little teeny black hole. And that is producing scales across our universe from universal size to subatomic part, and that the holographic nature of the interference pattern of these little Plancks creating all these waveforms produce a holographic solution in which every point contains the whole. There is discoveries that are occurring now in physics in which we are starting to understand something that's been very puzzling for many years in quantum theory. Einstein called it spooky action at a distance.
Einstein's spooky action at a distance theory refers to quantum entanglement, which states that the measurement of one particle will instantly influence another particle, regardless of how far apart they are. So when you modify one particle, the other one modifies itself almost instantaneously across vast distances.
This was a consequence of the exploration of quantum theory early on, and Einstein thought it was crazy and spooky, and then eventually it was confirmed in laboratory. In laboratory, we discovered that this is true. You can shoot a laser at a carbon particle, for instance, and it will emit photons, and if the photons are emitted away from each other, they will travel through a very specific vector, and at a certain distance, you can put a polarizer on one side and then a detector behind the polarizer on both sides, and so that the polarizer will change the angle of the one photon on one side, and then the detector will pick up the new orientation of that photon. And we discovered that it doesn't matter how far the distance the photons travel before they get modified, before the one get modified, the other one will be modified instantaneously as well. Because we've put the polarizer close enough to the detector that even at the speed of light, the information could not be transferred to the other one, yet the other one arrives at the detector with exactly the same polarization. This is called entanglement in physics. Particles can be entangled. They have to be in a certain state to be entangled. And so we think that there's particles in the universe that are entangled and particles in the universe that are not. Is that true? How do we know that's true? In fact, we don't. In fact, we could think that we could have a universe in which all particles are entangled because they all came out of the same point, just like the two photons came out of the same carbon particle. And so that all particles that came out of the early universe are entangled. And we don't know, because when we wiggle the little particle on the end of my finger here, we don't know, maybe there's another particle somewhere else in the universe that's feeling that tickle. and it's laughing, but we don't know because we don't have that side in our laboratory to realize that when I tickle this one, it's entangled with this one. The whole thing could be entangled. This appeared to me early on in my exploration of physics. And it became clear that maybe some of this the entanglement that's occurring at the quantum level is the same dynamics that is going on in black holes.
Entanglement at the quantum level may be the result of wormholes that are developed in the structure of space, connecting particles together. However, wormholes are a consequence of Einstein field equations, not of quantum theory. These would be quantum-sized wormholes that are at the Planck scale of the structure of space-time. This new understanding was developed by Leonard Susskind and is described as ER equals EPR. E stands for Einstein. R and P are initials for collaborators Boris Podolsky and Nathan Rosen. So ER equals EPR suggests that the key to their connection can be found in the space-time tunnels known as wormholes, like subspace shortcuts physically linking distant locations. So ER equals EPR is a way of saying wormholes is what produce entanglement at the quantum level.
This new view is emerging as well from our equations now, where basically we're showing that we have embeddedness of wormholes and black holes from universal size to subatomic size. So think of the black holes as being the boundary that's created by all the Planck spinning in one region, right? And the wormholes, the vortices that would be produced by the spin as it goes, as it extends from the black hole structure. ER equals EPR is basically thinking of it a little bit differently, but is as well very useful. And it returns, and it has to do with this holographic solution in the Standard Model that says that the entropy or the temperature of the black hole is the result of all the little Planck information on the surface of the black hole. When this Hawking radiation happened, when the black hole absorbed one little Planck particle, fluctuation of the vacuum, and emits one, these particles, this pair of Planck particles, are entangled, just like the two photons that emerge from the carbon particle in our experiment. And so imagine these, one is falling into the black hole and the other one is entangled with it, but going away from the black hole. And then imagine that particle gets caught in the gravitational field of another black hole. And now it spirals in and falls into the other black hole. Now these two black holes are connected through this wormhole that connected the entanglement of these two particles. A little teeny Planck-sized wormhole. Except there could be many, many of the particles that fell into the black hole and many, many that fell in other black holes and so on. And then go back in time and think of all this stuff coming out of one black hole, one point. And then you will see, you will visualize, you will understand that all of these wormholes would be like a spider web of information network emanating and connecting all of the black holes, all of the singularity, all of the particles in our universe. So we live in a web of information exchange. And this is really what our equations are showing, is that when the information is exchanged between the interior of the singularity, the interior of the black hole, no matter at what scale, it's exchanged with the whole as well through the wormhole network. And when the exchange happens between one particle and the whole, the energy that it produces is what we call mass. And that is what we call our reality. This network of information has been imaged and is being discovered now. Recently, we have seen that when we look at very large structures in the universe, they appear to be connected through these filaments that connects very large like superclusters and cluster structures in our universe. And when we look at that from far as a whole, it looks very similar to a neuron network in your brain. This is all very interesting evidence of scaling of this network across very large and very small. Imagine the network structure of all the wormholes occurring at the Planck scale. And then these network making larger network at the proton scale, and then these making larger network at the solar system scale and at the galactic scale and so on, so that everything is connected through this invisible Planck structure network of information, moving bits of information across the universe, so that when one bit falls into a black hole here, it can come out somewhere else in the universe. If this is true, then the concept of evaporation of black holes disappear. We are now no longer losing energy. The energy is always recovered in the universe as it exchanges information across all nodes.